Hello. I am delighted to be here today. So got a couple minutes late start, so apologies for that, but I'll have you out of here before lunch for sure. So my name, again, as she said, my name's Wieczorek. I'm an SRE at the United States Digital Service. I'm going to talk today about implementing a black box monitoring system for all public-facing web applications in the federal government. That's about 30,000 of them. And how we use the data learned to integrate with new systems. So real quick, while I'll go into my second slide, even though it's not up here. I'll talk to you a little bit about the digital service in general and the mission and the kind of things we work on. So we were founded in 2014, right around open enrollment season for healthcare. And essentially what happened is the healthcare.gov was a new web application that was my computer restarted. The staff here has been wonderful. This one's on me. So the digital service was founded in 2014, right around when healthcare.gov came out. So you might be aware, healthcare.gov is the web application for everyone to sign up for healthcare during open enrollment. Now that means tens of millions of people are going online during a 6-week open enrollment period. In 2014, when this was first released, it meant that tens of thousands, tens of millions of people were logging on to see if they're eligible for healthcare, to sign up for healthcare, and to find out what their options were. Promptly, as soon as that happened, the website fell over on about November 2nd. So what the president at the time, President Obama, did was call in engineers and designers from Silicon Valley, tech-focused people from all over the country, primarily from Silicon Valley at that time, to come in and triage some of these systems to find out what was going on and essentially fix everything. So that led to fixing healthcare.gov, and it led to bringing a team staying inside the federal government called the United States Digital Service. Now, we're still around. We're working on big citizen-facing issues. As she mentioned, you'll find us at the VA working on critical veteran-facing tools. You'll find us at Health and Human Services working on the expansion of Medicare and making sure that that doesn't fall over when it expands. Working on login.gov at GSA, where we implement a single sign-on for the entire federal government, so you don't need a separate logon for every single government website that exists. So we're working on these critical issues. My PowerPoint is opening. And let's get started for real. So we deliver better government services to the people. We're engineers, we're designers, we're product managers, and we find and we solve big problems. So one of the problems, though, is how do we find the problems? How do we know what's out there? How do we know what crises are happening? We're a very small agency. We're less than 200 people. We serve tours of duty. We come in from tech companies, we fix things in the government, and then we go back out to the private sector and learn more things. We're mobile. We can be at your agency tomorrow with virtually no paperwork. So we're totally free to come on and fix these big problems. The big solution so far has been to step in when there's a crisis, like healthcare.gov. A couple quick examples on that. The 2018 California wildfire season was the deadliest and most destructive in history. People were logging on to EPA's airnow.gov website so that they could look at particulate matter and ozone and where it was in California, so they could know where they could go and what precautions they needed to take when they went outdoors. The influx during the wildfires meant that the entire site went down, a critical citizen-facing service that could help people's lives during a time of crisis went down. During that time, logging on to airnow.gov, you should have been able to see something like this. Particulate matter and ozone, where it was spread out through California. Instead, what you saw was 404. Occasionally, you'd get lucky and get a 500. but mostly it was a 404. The latter half of 2018, the site looks something like this. A lot of redirects. The green means it's up, the orange means it's down, the blue is redirecting to the old version of the web application because the new version had fallen over. So we're there now. We're helping out. We're hoping this doesn't happen in future wildfire scenarios with airnow.gov, but we could have helped a lot more had we come in early. So how did we find out about it? One of my colleagues happened to be checking airnow.gov to find out if where the ozone was and where the particulate matter was located. So another quick example, the US Patent and Trademark Office, the site went down for submitting patent applications in August 2018. This was a 9-day outage, August 15th through August 23rd. These are not official numbers, but it costs about $4 million an hour in service disruption, which meant that a 9-day outage meant that there was about close to $900 million lost. We could have gotten in, we could have helped a lot earlier. How did we find out about this one? Twitter. And the Wall Street Journal, to be fair. So how do we get ahead of problems like this? How can you, if you're in an organization that's similarly disconnected with various silos, how do you get ahead of things like this? So the idea we had was to proactively implement monitoring for every .gov domain, every .gov public-facing web application that services people that are trying to get services from their government. When you're doing something like that, what targets do you monitor? What do you monitor for? Is uptime the only important thing? Do you care about latency when you're black box monitoring a third-party service? But like AirNow and like the US Patent and Trademark Office and like healthcare.gov, these services can be critical to everyday lives. And so it's important to get started and get in early. So there are a lot of services in the .gov space, which is why we have the 25,000 number at the outset. Luckily, we got a kind of a jump start there. The Office of the Federal Chief Information Officer maintains public records for compliance for things like TLS. Is TLS enabled? Are you compliant under various executive orders and binding operational directives? So we're able to pull down a list from there of .gov web applications. It's 26,049 in all. On top of that, there's a lot of .mil endpoints, which the military runs, and those also have a lot of citizen-facing services for service members as family, and people after they leave service and become a veteran. Analytics.usa.gov tells me that there are about 3,000 domains with higher traffic. So the initial thought might be just monitor the more higher traffic domains, but higher traffic does not necessarily mean critical service. You're going to have high traffic things that are effectively static web pages or redirects to new versions of applications. And then you can have small applications that may never hit a high traffic type of scenario, but they're critical for vulnerable populations. Think seasonal migrants coming in to the United States for the season to work. Being able to get to the library or use someone's phone to access a service when maybe they only have one chance to get in there and do that, it can cost a lot of toil in their lives if that small service is not up. So some of these are large, some more critical, but the idea was monitor everything, about 30,000 in total between the .gov and .mil endpoints. So the MVP for this looked like just something really simple, using Python's request library and a CLI, effectively going through, iterating, and sending requests, sending GET requests a couple times a day, just to keep a log of when these services were up, what they were returning, and dump that all into a JSON file. But of course, we're all excited to build a new system or work on some new software. Some issues here are that there's already really robust software out there. There's robust open source applications that one can use and leverage to build things like this. Additionally, it would have taken a lot of extra work to kind of iterate on this super simple MVP. So we expanded to a more robust architecture, using things like Prometheus, Grafana for dashboarding, and InfluxDB for keeping long-term analytics of what we were pulling down. So the initial architecture looks something like this. Prometheus making all the calls and kind of acting as a control plane. sending requests through HA proxy to a number of black box exporter instances, which are really the things doing the heavy lifting, sending requests off to these 25,000 web endpoints, storing everything in InfluxDB afterwards to make sure that we have them for long-term analytics so we can look at trends over time, and then dashboarding on Grafana, which was shockingly difficult with so many pieces of information. Alert Manager was big here as well, writing alerting rules to make sure that we're not getting paged all the time. And of course, that raises a question, should one even be paged for a third-party service that you don't run yourself? But like the presenter before me was talking about, sometimes Slack is great for this. Shoot everything over to Slack, and so that way you can go through and look at what's going on, and you have a channel to know that this is working, and to get eyes on the various services that may or may not be going down, and triage and make sure that it's an application that warrants our engagement. So what do we monitor? Basically, HTTP 200 responses, looking at performance and availability. Uptime is more important because that means that a site is down. But keep in mind, the reason we're doing this is to look in and get a toehold in these agencies and with these systems so we can help make them better. So sometimes just having super high latency on things will make it so that, or seeing super high latency will make it so we can go engage and say, hey, this is a bad experience for the person that's trying to access a government service. So this helps us seek out various targets to pitch and say, hey, we're here, we can help you out. And often we get it before their monitoring team is even aware of it. In government, I've seen more than one time where the alerting infrastructure involves someone sitting by a phone and waiting for a user to call and say your site's down. So tuning Prometheus and Blackbox were some of the more difficult things to do here. Dealing with scrape intervals and timeouts. Shockingly, when you curate 30,000 endpoints, a lot of it comes down to spot checking what's going wrong, finding black box probes that are not working or returning a 0, indicating that they didn't do their job, and figuring out why this is the case. Now, when you're running your own infrastructure and when you're controlling the servers that are being monitored, you certainly are in a situation where you can reason more about why this is happening, why probes are failing. When you don't run your infrastructure and you're initially returning 8,000 errors, you can't go through every single one of them. You have to spot check them. So the name of the game was going through, changing configurations by spot checking and finding out what would help any given probe that failed, make that change and see how it affected things overall. So with a lot of triaging, a lot of curating the content out of these 30,000 endpoints, we ended up having a successful Prometheus black box exporter targets, more than 25,000 up. So that's difficult with so many services, but really the hard part is looking at it, monitoring it, seeing what's going on. Any expensive queries in Prometheus would bring it down because you have 25,000 different endpoints and they all have time series data. So that would bring down Prometheus. Grafana is even worse because it has a full GUI. And so when one tries to run a time series data on 25,000, not only is the data not that useful, but it also crashes your browser every single time. So you have to be incredibly careful. I fell in love with single stat panels at that point because they're quick to load. They give you a really high level piece of the information. And we don't want to be in a situation where your SREs are sitting there looking at dashboards all day. We want to be guided to the correct dashboards. So segregating information into groups, being able to drill down on any given application or set of applications. For example, every web property that GSA runs or every web application that VA runs. You can dig into that kind of detail and reason about what's going on at any different given agency because every agency runs their own infrastructure. So that was all going well. We got some good data, good alerts, being able to see everything in Grafana, and then we got a scary email from Amazon. This is what happens when someone's being hit by your probes and they complain about things. You're hitting them a little bit too often. At the time, it was sending a GET request about every 3 to 5 minutes. So because Amazon can shut down your entire account, this is kind of cause for panic. So the initial thing we did was up the number of black box instances from 3 to 5. So there's more IP addresses sending these things. As an aside, HA proxy made this super easy and validated the decision to go through a proxy to black box exporter instances rather than messing with Prometheus relabel configs. Adjusted the scrape interval significantly from 3 or 5 minutes to 15 to 30 minutes. Because really, we just need to know if the service is down. We don't need to know that it's down for immediate failover so that it can continue to go up. We need to know that it's down so we can step in, take a look, and decide whether to engage on something, whether to contact the agency and say, hey, your site's down, this critical app is down, we can help. So, but this also caused costs to rise. This is a really small application. And when only your 5 black box exporter instances are, plus your HA proxy instance, are costing you $700 a month, that's with your M5 XLs on AWS for anyone who's curious. Those are about $138 a month each. It costs a lot for what should be a relatively smaller, low toil project. So by far the best thing to come out of this, this Amazon abuse email and the panic there was to look at designing our infrastructure in a slightly different way. It was to ditch all the black box exporters, to ditch HA proxy, and move over to AWS Lambda and API gateway. So that's certainly more complicated on the front end. You're working on more than just configs with black box exporter and Prometheus and HA proxy. That's all fairly easy to do. This involved pulling modules out of black box exporter, designing your own Go function to run in Lambda. And it also has the downside of locking you into one service, in this case, AWS. And it's also harder to debug black box exporter errors. But the architecture went from something like this. We got rid of that. And then we ended up with the API gateway and the AWS Lambda. This made things simpler because part of our architecture is now static. It's nothing you have to know about, reason about, or run. But by far, because when you're running a server, you're paying for it as long as it's up. With API Gateway and Lambda, those are serverless type concepts, so you only run what you need. So your cost every month scales directly with how much you're using it. So our cost in this case dropped from $700 a month for just the HA proxy and black box exporter instances to $70 a month, which is a huge savings when you consider that it eliminates a lot of the toil of managing your own infrastructure. So what's next here? I'd like to write our own exporters. I'd like to get past the front pages, like, for example, on a login flow, where the front page may return a 200, but then post-login, you return a 500. That's not useful data. It's not useful to say your login to your application is returning a 200 when it returns a 500 on the back end. But that goes deeper than simply sending probes out to the front door of web applications. You need permission for that. You need to engage first and get test user data or test user login so you can start running that. So what's the result? Now we have data to show uptime for services. We have the data to act quickly when a service goes down. We have some analytics that say, okay, these things are happening. Your service is in danger of going down. We can engage. It allows us to show SRE concepts across the government, build better citizen-facing services, and it opens the door on top of that for product managers and designers to show how to build user-focused designs to make things better and PMs to be able to release things better. So you may recognize this chart. This was created by our first administrator of the US Digital Service, Mikey Dickerson. I found that most government teams focus on the top 2 or 3 or maybe 4 of these. And this setup, having proactive monitoring, allows us to go in and prove the value of monitoring and SRE concepts, incident response and postmortems, and then they can build their applications and do their capacity planning and testing based on industry standard practices. So a few lessons learned before I let you go. Proactive monitoring allows immediate incident response. It's much better than seeing something in front on the Wall Street Journal or on Twitter. And it also allows us to train teams to expand our influence through that training and to evangelize a lot of these concepts through government. Sometimes targets don't like it when you're sending a lot of requests in rapid succession, rapid meaning 3 to 5 minutes. Be careful with this. You can get your account shut down, which would be horrible. But it helps prompt the move to Lambda, which spreads out the IPs. They're not tied to specific instances, and it was significantly less expensive. Dashboards with this many endpoints are extremely difficult. Any wrong move, even in testing, will bring down your dashboard, and then you have to close your browser, reopen everything, reopen Grafana, and get back to where you were. So it definitely was a lesson in knowing what kind of time series data would bring down everything. But it also allows you to drill down for services at any given agency, find out if everything's down at an agency. And then you can engage on a larger scale because the agency infrastructure is down rather than just one web application. Alerting is very hard, but alerting should be what guides you to your dashboards. You shouldn't be watching dashboards. Being able to say, okay, this critical web application is down according to this alert I just got, and now I'm being directed to the proper dashboard where I can see when it went down and the circumstances around that is huge. And finally, tuning the monitoring settings normally is not so easy on Prometheus and Blackbox because there's a lot of tweaking that needs to be done. But when you're dealing with so many services, it's more like a game of guess and check. Pulling in, spot checking failures, changing your configs so that everything works. And also, back to the abuse email, let's be nice to the services we're trying to help, because we're not there trying to build our own database for some service and scrape web pages. We're just trying to find out if the service is up with a little bit more data on top of that. So longer scrape intervals, set your scrape intervals to what makes sense for your use case, and send head requests when you can, so that way they're not having to load the whole response body when they get back to you. If any of this sounds interesting, if working on large government-facing, citizen-facing services sounds interesting, we're hiring. usds.gov/apply. Our director of engineering will also be giving a lightning talk tomorrow evening, I believe. So say hi to him. And we have a booth outside. We're happy to talk to you. I promise we're not going to try to sell you anything at all. Thank you very much.